What should a young person today that wants to approach the world of robotics, hardware building in general, even with tiny bit of coding knowledge, or maybe none, right? What should they do?
Start building, start experimenting. There are now incredibly cheap kits that you can buy, or even stuff that you can download for free and make it yourself. So you can make, legged robots, robot arms, you can make whatever. So you learn how to program and how to do electronic like that.
What are the mistakes that you've made? Like the top two that you made. I know this was a curveball, but the top two mistakes, you called it upon yourself.
So I would say we were not careful enough at the beginning, and so we had a problem with one of the manufacturers that we hired to do things, which basically kind of took advantage in a way of our the fact that we were not structured as a proper company at the beginning. So we had to So now, I have this law that says if you spend €1,000 in lawyers now, you are basically saving €1 million in lawyers in like 6 years.
What is your advice to educators and people that want to become educators to engage, to create curiosity and impatience in kids? If you had to, distill it in one advice.
It's not an easy question because I always felt that if you are an educator, you feel it inside. You know what I mean? So it's something that you really perceive as a value. So for me, I think that education at every level is the only thing that changes the world. The world changes when people get educated and they understand the world around them better. They understand the relationship and the way the power works. Then they change, they push for change. So education is fundamental for changing the world. Everything else is, I guess it's a consequence of that. So it requires people who feel it. There's a lot of people that I've had as professor in my life who I knew that they were there because it was a salary.
What are you doing these days? What excites you? What are new projects you're undertaking?
So what I'm doing at the moment, I'm working on a project called Super Moderno, which at the moment is mostly dedicated to the history of technology, but try to talk about where the technologies that we all know come from, but with the objective to clearly get some younger people to understand where technology comes from.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi Massimo, welcome BitBuilders.
Hi, how are you?
Pretty good. I mean, I don't want to play the fanboy part too much, but it's really an honor to have you on. Some people might actually know you from the audience, because the audience is very robotics focused. But let me ask you if you can to introduce yourself to start.
Yeah, so my name is Massimo Banzi. I am an interaction designer. I'm a technologist. I'm also a teacher. I teach in design schools, and my main activity in life is to take technology and find ways to explain it in a way that becomes essentially a creative tool for people.
And what is interaction design? Because I feel like it's good for the Nexus story of a big part of your life.
Well, so interaction design is a sort of newish discipline of design, which is more about designing the way people interact with technology. So classic design that people know about, it's more concerned with the sort of visibility, so the not the visibility, sorry, the visual appearance of things. While interaction design is more interested in designing the interaction between typically people and technology. So it can be devices, services. So in a way, it tries to help design products and services that are easy to use for people.
And it's awesome that in Italy, I think we have. So we're both Italian, by the way, for the audience. If you didn't, get it by both of our names, we're both Italians, and in Italy, I think we have a long-standing tradition in design and in art. And there's particularly an institute in Ivrea, which is a small town close to where I studied for my bachelor in engineering. By the way, it's very famous for its carnival. That there's an interaction design institute, which as a story, can you tell us a bit about that and maybe walk us through?
I mean, so that Ivrea is it's an interesting town because it was for 100 years the company town of this company called Olivetti, which was a big, it still exists. It's but it was at some point a massive Italian company that was manufacturing first typewriters, then calculators, and then computers. And they were probably one of the very first companies to produce a transistor computer in the world back in the 50s. They developed the first desktop computer in history, the Programmer 101, in 1965. And then, in the 80s, for example, they were at some point the first computer manufacturer in Europe. They were selling. But then, in the 90s, they went into decline. And then somebody said, how do we give back to the city of Ivrea, which has this rich texture? And Olivetti was famous for being the first company to really apply design to everything, to the buildings, the products, the advertisement. It was Apple before Apple. So they said, okay, why don't we do like a design school? And this person who is unfortunately no longer with us, called Barbara Gella, she said, well, we could do interaction design, which is a new thing, and it's about how do you design digital products properly. So they took this beautiful building, which is to be the R&D building of Olivetti, which is like this beautiful blue, covered in blue tiles. And they basically fixed it and put a school in there, and they called people from all over the world. And I ended up there for like kind of randomly, because a friend of mine told me they needed someone to work on, to help the students on few projects. Electronics was already my passion when I was a kid. They needed someone to help with electronics. I studied electrical engineering in high school and a little bit of university. So I went. Obviously, I wasn't really qualified the way they expected, but they needed me. So I started going there 2 weeks. Then I came back for a few months. And then I stayed 4 years. So my job was to basically teach students how to use electronics to build prototypes of the ideas they had. And so part of this work was to figure out ways that you can make electronics understandable by people that don't have a background in technology. Because, it was very useful to look at the way I learned electronics as a child. because it was very experiential. I didn't have the theoretical background, so I just plugged things in. And that was kind of the now there are fancy terms to describe that, no? Learning by doing, project-based learning, all these kind of things. But effectively, we put together different methodologies to make something more accessible to an audience of people who don't have a lot of experience in electronics or software.
And that's actually a very good, it makes a very good segue for my story in getting to know, your, one of the projects that you contributed to, which is probably the most famous one. I think that learning electronics without having to know the basics of electronics is the reason why I became an engineer. Because I think it was my uncle. Actually, I thought about it today and I couldn't figure out who it was. I don't know if it was my uncle or my dad who came on once. I was already a nerd. I was, 12 or 13, and I was already, using the computer much more than my mom thought I should have. And so basically, he came on with this board with a small electronics kit, which I don't know still where they got. And I've been tinkering around with Arduino, which is the platform that you have co-created for years. I never stopped. I actually was looking for my Arduino here in my house in Berlin, and I thought I had it. I don't have it with me, but I have the electronics kit, so I'll probably buy one tonight because I got back to kick to just make something move, because it's more expensive to ship it from home. But give us an idea. How did that project start? So, what's Arduino? What does it have to do with Interaction Design Institute at Ivrea? How did that entire project come together? What's the story?
Yeah, so one of the key elements of interaction design is prototyping. You have to prototype the things you build so that people can test them, so that that what you're building is understandable by people. And one of the examples I always make is that when you go around the world and you buy a ticket in the subway or for the bus, every country has a wildly different experience. Some country is like beautifully designed, you press 2 buttons and something comes out. And in other countries, you have to kind of navigate a ton of things. You don't understand what you're pressing. So clearly there's a difference between something that was put together to make it simple for the engineer to ship the product and something that was put together with an effort for the user experience. And that's the difference, prototyping and testing with users. So if you want to prototype with electronics, there was an advantage that, when I started learning electronics as a kid, we used to use individual parts like transistor, capacitor, resistors, no? And obviously everything is kind of complicated there because you have to understand electronics quite well to understand how to build a complex circuit. But in the meantime, this particular type of chip called microcontrollers start to become available. And so these are very small computers on a chip. And they were quite inexpensive. The students were using some product coming from the US, but through all the different import taxes and everything, when they arrived into Italy, they were about $100 €100 per piece, which was a ton of money. And also, if you are worried, because €100 means that if you break it, it's money, so the students are worried. I wanted something that you could build yourself that would be open source somehow and would use microcontrollers that you find anywhere. So I did a bunch of experiments with my students to replace these platforms. So I started to use this microcontroller called PIC chips, because back in the days in Italy, it was very easy to buy PIC chips because people used them to hack satellite receivers so they could watch the game.
Very Italian.
Very Italian. So they wanted to watch football, and they had this smart card type thing with a microcontroller on it that you could slide and you would program it. So you would find these microcontrollers everywhere. And so I started playing with that, and I built a little platform that was called Programma 2003 in honor of the Olivetti Programma 101. Then one of my students took that work forward and built a platform called Wiring. And then we took the work that he did on wiring and we extended it further with a group of my friends. Somebody that was teaching, another student, some other people from them. So we put together the experience of basically 3 teachers and a student, and we kind of developed Arduino as something that was simple, that you could assemble yourself. So it's a little motherboard. We switched processor to a different maker that was easier to program, and where there was like a very nice open source compiler. So basically the idea was we take all these different open source softwares that are incredibly powerful but very difficult to manage by a beginner. There was this great tutorial by the MIT which started off saying, this is very simple, let's compile the compiler. And I was like, imagine my students compiling a compiler and then building the whole tree. It's impossible, no? So we figured out ways. So we took a lot of inspiration from this other project that was done at the school called Processing, which was a programming language for designers and artists that was started at the MIT and continued. So we took a lot of the user experience from that. And then we said, okay, we take all these open source parts that are complex but powerful, and we wrap them into a coherent user experience so that you have a super minimalistic user interface. There are 7 buttons. You press a button and a bunch of things happen behind the scene. And you should not worry about what happens until you have the tools to understand what happens. Since we were using C++, and we are still using C++, the idea was C++ is scary for a beginner. Also, you need a make file, all these other. So what Arduino does, it basically gives you this very high-level framework to develop on microcontrollers, and the whole build process hides all the ugly parts. So you press a button. So if you want to do like a minimalistic piece of code, 7 lines of code, and you have something working.
You have a blinking LED, you have a potentiometer that can, something easy, but it's incredibly powerful to get to know electronics and understand.
Yeah,
how these
in
things
a
work.
previous life, I was developing in Java, and I was a software architect, and I was doing Java development, and I loved Java. But one of the things about Java was it was incredibly verbose. So before you did anything, you had to kind of write a bunch of code. So one of the things that we decided, borrowing from processing, was let's remove everything, make it super, super simple.
And it's incredible because from there on, I think it already existed, and there you have to direct my thought, right? But I think what happened in the last 15 years is that even the electronics industry that goes on and builds components, like anything from the servo motor to the potentiometer, the LED that I was mentioning before, temperature sensors, humidity sensors, all of the stuff that you would find in back 15 years ago would have been something niche that you would have to know how to integrate into a hardware system. Now becomes something that you can prototype with. You just need Arduino, a bunch of cables, a prototyping board, like a whiteboard, and you can do fun stuff. And for example, like I've seen strange things, like in Vietnam, in the school that I was volunteering in, I've seen an Arduino that was powering their alarm system. They had a tiny camera. They wrote some code to turn it on and off. Whenever it saw some movement, it would fire a siren. As easy as that. And I'm pretty sure it's actually very easy code, and it's very easy to to put together. And so I think it's inspired a ton of kids. And in BitBuilders, in this podcast, we try to understand also the...
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
The business case around and the commercialization case around these mega innovations that are coming together. And I want to try to understand with you, through now in your story, this is a great project to get people close to the subject. How did that evolve? How did you make it into what today is Arduino?
One of the interesting things that happened is that since in Ivrea people have been manufacturing electronics since the 50s, clearly there were, although the big Olivetti was kind of or almost closing down, there was still a huge amount of the supply chain left. So I found company making PCBs. I found a company that was assembling circuits. So I started to hire them to do prototypes, to build prototypes. And at the beginning, I only made PCBs, so the blank circuit, and I gave it away to people. As always, here's the circuit, here's the instruction, build yourself the circuit. And then, we started to do a lot of workshops around Europe. And we realized that there was traction and people liked it. So we started to say, hey, why don't we... So we contracted with the local manufacturer in Ivrea. They was basically manufacturing the boards. And then they were sold to people that wanted something pre-assembled. And the model that we chose was that basically Arduino would register the brand and be the brand. Everything would be open source, but if you wanted to call your product Arduino, you would have to go through us. So we kind of made a sort of a model-like fashion, so which was based on licensing the brand. So we had 3 companies, I guess, manufacturing products with Arduino written on it, licensed from us. And then this is how we continued. So Arduino, the company, was mostly doing R&D and marketing and managing the community. And then there were manufacturers that were building, selling, and giving us a royalty.
Okay, that makes sense.
That was the model. Everything was open source software and hardware. Now, the latest stuff that Arduino does, it's more professional stuff. It's very high level. It's very high density, multiple layers. So it's very complex. So that stuff is not fully open source for a couple of reasons. First, it doesn't really help beginners to have a file of a PCB that's got 8 layers and it has like massive BGAs on it. It doesn't really help them. So they have access to the schematic, they have access to everything, and also because it makes it too easy for people to clone. So there's unfortunately a massive market for clones, and who abuse also the Arduino trademark. So it's always a bit of a struggle to do open source, because over the years the market started off as people appreciating the nature of open source and learning from it, to people taking advantage of open source and never really contributing anything.
Okay, that makes sense. So the downside of hardware open sourcing is that there are some companies that will basically sell your product by simply being fast and cheap at manufacturing it. And there's manufacturing bases that are cheaper than Italy, to go and build your own electronic board. And so I'm very interested.
I have to say one thing. So Arduino manufactures 95% of what they do in Italy, and clearly the price of an original product is higher. But it's not like fashion where, it's like €1,000. It's like 25 euros for a board. So if you live in a Western country, it's not an amazing amount of money, Obviously, you get Chinese-made products that are also made with, lower quality components and all of that get sold for much, much less. They give you a ton of problems. But I guess there's a category of kind of, customers who prefer to waste a lot of time and spend a little money. The people who are actually building something meaningful, they prefer to spend a little bit more money and be sure that it works and be able to do things very quickly.
And I can also certify it's incredibly valuable for money. It's a good value for money because I actually gave it as a Christmas gift to my little cousin. One of the kits that you guys sell on Arduino.cc on the website. There's a kids kit, which I don't remember which one it was, and he's going crazy. It's like a €60 gift that makes a kid happy for years. I was like, and not only you can actually build real things with it. And I really want to touch on what you said before. So there's a professional case for Arduino, and just to let the audience know, in the most sophisticated robotics lab that I've been in, a company building very complicated robots, they need industrial motors controlled, perfectly, etc. They still use Arduino to do prototyping. They probably don't use it in the production board, but they use it to do prototyping. So to understand the breadth and depth that you can use Arduino for, that's pretty much the case. And I want to double down with you on the professional uses of Arduino. Can you walk me through what those are? What's the demand on the market? Why would you, as a professional user, buy pro version of Arduino? And what's that, right? What does it entail?
Yeah, so Arduino, when it was born, was a prototyping/teaching platform. So it was a simple 8-bit processor. It's just very simple to use. Over the year, people have asked for more performance, more features, but also we started to see people using Arduino in professional application. For example, we make this product called Arduino Mega, which is kind of it's still an 8-bit processor, but it has like about 60 something IOs, and it has quite a bit of memory. So people started to use it as the main board for 3D printers. Or I've seen multiple cases of people who use that for industrial automation. So I actually know a case of an Italian company that they were a PLC system integrator. They had some trouble. They closed down. And then they basically reopened, and they had a project to do for a car factory. And they basically took an Arduino Mega and used that as the controller. They basically hired a bunch of kids out of school, because now, in a lot of parts of the world, kids in school learn Arduino. And so they were basically to build this cheaply and quickly. And so we started to reflect on the fact that people wanted more professional products. So we started to build more sophisticated boards with high-end multi-core microcontrollers. So, for example, one of these boards is called the Portenta. It has a very powerful STM32 microcontroller. And, for example, we worked, a company in Barcelona built MicroROS for it. So you can integrate it easily into a robotics application. And then we also built on the same format a quad-core Linux machine. These products, these latest pro products, as they call, they're all designed and manufactured to industrial standards. So they come with all the certification that you can stick them into like you can put them in a factory, Because that's the idea. A lot of times people have solved problems with Arduino, and they were kind of switching to other platform because they said, well, I don't really feel like putting a €20 board inside something. So we started to build these more advanced boards. And then what happened is that we started to we built a PLC, a micro PLC, in collaboration with an Italian company that does industrial electrical engineering or electronics products for 70 years, called Finder. They were famous for relays. So we built this PLC, which can also act as a gateway and do a bunch of other things. That is seeing quite a lot of adoption also in the US. We had some big customers using this Opta PLC in the factories, for example. So one of the things that has been very interesting for me is that the R&D engineer on the product might feel a bit, no, Arduino, I'm going to design everything from scratch. But the people who run the factory, they do a lot of R&D anyway to actually run the factory. And they're like, I don't have time for this. So when they discovered that they could get this PLC, put it in, and then they could program it with Arduino, and they could touch a bunch of other expansions and things, they were like, great, perfect. And so we have a bunch of system integrators in the US who are using this because the simplicity. We also have this, motto in Arduino that what is simple for beginners is fast for professionals. The reason why you see all that prototyping happening is that if you have an idea, you can, grab an Arduino, connect a few wires, and then program very quickly. You can get a prototype running in a few minutes. So the speed from idea to something working is the important factor in this case.
And I mean, it's the hardware prototyping logic that I don't think it became, I don't think it started with SpaceX, but I think it became an obvious philosophy, at least with them in the last 20 years, is that you want to ship your hardware product, your MVP of the hardware product, the P0, as fast as you can. And so you just want something that works. And then if it's not, exactly what you're going to use in production, whatever, but you're actually going to spend a ton of time with that prototyping board. And then if you complete that prototyping offering with something that is more industrial grade, you have an entire life cycle of a hardware company covered. I think what I admired the most is also the community that you guys have created around Arduino. You can, anyone from the audience, I challenge, go online and go on GitHub and look up just Arduino and see how many pages you have to scroll to get to the end.
Yeah. One of the big things that were introduced in Arduino was this idea of libraries. So there are these basically C++ classes that can basically wrap any sensor. And then the community started to pick up on this. And they basically, we have almost 5,000 libraries, of which we built probably like a couple of hundred. So the other 4,800, they're all community built. So again, another challenge. Come up with the name, with the part number of any sensor you can think of, and then put it into Google with the word Arduino next to it. Boom, you will land into the Arduino library repository, and there will be one or more libraries that wrap the sensor. And the other thing is another value. If you're building some project and you want to do like a prototype very quick, you just bring in all the different, I'm doing a project that we're going to use in the class next week, and I needed to control these brushless motors. There is this library, Simple FOC. I just downloaded it, and boom, boom, boom. I was controlling the brushless motor. I don't even know what it's doing. I just know that I have a little motor driver called Simple FOC, and I have a library, and boom. So a bunch of things that I want to do, they are already packaged up as libraries. Then obviously, if I want to make my own, customize whatever, I can. It's all open source. I can open it up and look inside. It's incredibly convenient.
It's convenient, it's powerful, and actually the software advances of the last 2 years will actually make it even easier. So LLMs generating code will actually make this, the first phase of prototyping, even faster. I can, plug all the components in, tell my LLM what I have plugged in, and ask it to do a first run, right? And it can already, give me the code, can paste it into the compiler, simply compile. That's as easy as that. And you have something that's working. And what do you think of that? Like, how is Arduino thinking of advances in code generation, if any, right? I'm just really a spontaneous question.
No, we experimented with that. I think the The issue with Arduino is that there is maybe not as the different models that do coding. They haven't been trained with Arduino code specifically sometimes. So sometimes they hallucinate a little bit badly. I remember I tried this experiment and I asked ChatGPT something difficult. And he wrote this code in Arduino that looked amazing, and it was based on a library. Then I looked for this library. The library doesn't exist. So what the thing he hallucinated the existence of a library that has 20 methods that solve every problem that I pose. So thank you very much. No.
Now write the library.
Now somebody has to write the library. So I think there is, but we did some experiments. If you use some techniques where you integrate the knowledge of an LLM with specific knowledge that you add yourself, so there are techniques not to integrate the knowledge, then it starts to become quite useful. But, it's... But yeah, I mean, it's useful for some. You need like an LLM that's been specifically tuned to work on microcontrollers, because the problems are different than Python, no? So the LLM
fair.
is really good at Python, but then when you try to do like
C++, a bit less.
Yeah.
No, I guess that was my only, actually my only touch with C++. Actually, I had two. One was Arduino, which, by the way, it's a very simplified version. If you really have to write it, as you said, you have really condensed method. And then it was this exam in my first year of university that I have to critique. Is like I had to write a program on a piece of paper and write down as an exam. I had to literally write down a program in C++ on a piece of paper. That's super against every interaction design class that you can ever take. But beyond that, so this is one thing, and it's code generation. But in BitBuilders, we have explored a lot the topic of new hardware in robotics and what that means for a lot of industries. So we interviewed a bunch of people that are building for traditional industries: construction, inspection, logistics, aerospace, which is not traditional, but like these three at least are. And then I've been thinking, to ask you this question: where do you think Arduino needs to go in the next years to converge / kind of like be ahead of the curve when it comes to prototyping and building robots and anything that's automated? We've seen NVIDIA jump into this. So like, what should we expect from Arduino?
So a lot of good material there. So I think Arduino has to, I started looking at the possibility of using small LLMs. So I did a bit of work. One of my last big projects inside Arduino was working on TinyML. So the idea that you can run machine learning algorithms or AI algorithms inside the small microcontrollers. And this culminated with us doing working with Harvard, and also Harvard University built a book now on how to do TinyML, where they use this little 1 inch by 1 inch board. It's a smart camera that can run Python and has some machine learning on it. So they did a book on that. So that's an Arduino product. It's called Arduino Nicla. So again, it's great because you can train an algorithm somewhere else, and then you can basically compress the model, and you transfer the model to this thing, and the Python runtime on this microcontroller can basically, use the model that so you can do computer vision, all the other things. So we did that. I think now it's interesting to figure out LLMs are becoming smaller and smaller. The hardware is becoming powerful and powerful, but also these LLMs are becoming more and more optimized. So I was playing around with Phi 4 from Microsoft, which is like I think it's a 7 billion parameter model, I have to say the answers he was giving were pretty amazing. So there is a trend in smaller and smaller, smarter and smarter models. And there is a trend in hardware that has enough acceleration. So you have processors from different companies like NVIDIA, Synaptics, Qualcomm, that combine a Linux machine with some AI accelerator. So you get very good performance on a little embedded board. So I think one of the areas where Arduino will have to expand is to how do you make that something that you can integrate into your system simply? How do I, so there are a bunch of algorithms that you can run on this particular hardware, but how do you make it simple? And how do you make sure that you support the platform long term? For example, when this new development board from NVIDIA came out, I was on a bunch of forums, and I saw a bunch of people saying, guys, let's be careful because the last time NVIDIA launched a board like this, then they basically stopped supporting the software, and I have an expensive paperweight on my desk, no? At least one of the things that Arduino has been doing pretty well is that there are platforms that we have been supporting for 20 years. So
Continuity.
you know that if we jump on something and there is traction, we already had 4 years ago in building a Linux machine. It was very easy to use for an end user. So I think there's a direction there. An Arduino plus acceleration to simplify computer vision, LLMs, all this, on the edge.
Of course. So on the edge for the benefit of the audience, on the edge computing means you can do computing tasks on the board. You don't need to be connected to some server that's doing that for you and then shooting back results. No, you don't need to. Obviously, you can. And that the beauty of edge computing is it allows applications with very low latency. So you can basically, run a robot that's deciding in real time what to do.
If you are dealing with sensors and all the other things, if you have algorithms that can run efficiently locally, you avoid having to go to the cloud for whatever. So you can actually solve a number of tasks locally.
It opens up the solution set for robotics. The solution set, it's also a function of how much computation can I do with my robot in less than a second. Can I decide, should I move off the way? Should I pick this up while the scene is evolving? I'm very curious to understand. I mean, this has taken a very nerdy tangent. I love it. That's the way we want to do this podcast. I want to ask you, what have you seen? And I'm asking this to you because you must have seen a lot of them. In terms of models that help robots interact with the surrounding environment, what have you seen that's incredibly powerful? Because we still don't have that. We can generate text, we can generate media, etc. We cannot fully comprehend the scenes, right? So we cannot, as you can predict the next token, which is the next word, you can't really fully, easily, and efficiently predict the next thing that's going to happen in a physical environment. What have you seen?
There's a bunch of interesting computer vision algorithm out there. Like Meta has released multiple versions of this segment everywhere algorithm. So when you look at a scene, it will segment out all the individual objects. The algorithms that can identify individual objects in a scene have become, I think you could run a lot of them on the edge with a very reasonable precision. So there are actually ways that we can start to understand a little bit better what's going on around us, and I think that's nice. I think Hugging Face started to do interesting because Hugging Face became famous for basically hosting LLMs in a way, but they actually hired person that works on robotics, and he's been developing a bunch of algorithms for robotics. He's also been developing like a $10 robot, so that you can like a mini robotic arm, so that you can kind of learn how to apply these algorithms to the robot. There are some things are happening. There are also companies like Archetype AI who make these algorithms that are able to understand, to extract meaning from sensor data in a way that's more advanced than when we were able to do before. So there's a bunch of other things that put together, or this is a bit of a different weird tangent, but I'm also kind of helping a startup which is based in Zurich. And one of the projects they're doing is they basically allow you to program robots by basically you give them the documentation of your robot, and they learn how to program the LLM, the model they have learns how to program it. So that when you kind of design your application, you don't have to know the specifics of the specific robot you're using, but the system learns from the documentation. You say what it needs to do, and this generates all the different commands. So you can integrate this stuff, so you can become independent from the robot model. Advanced computer vision, the ability to respond quickly to sensor data. I think it's getting there pretty
Coming
nice.
together. I've actually hosted in the office Ivan from Archetype AI, one of the founders. I know one of the other founders. I know he's Italian, and he's actually explained to us, scene understanding, so representation in text of what's going on in a scene dynamically is actually an incredibly powerful tool to, you can imagine monitoring a factor, right? So for the benefit of the audience, the concept of physical AI that they're developing and a bunch of others, right? They're just a case study. You can look at a scene and see what's happening. What that means is that you can plug that into an API that responds to the things that happen. So if there's a factory that you're observing with a camera, there's a bottleneck in a conveyor belt, you see the conveyor belt bottleneck, the physical AI can basically command stuff without having to having previously seen exactly the same bottleneck and recognize, being trained on exactly the same thing. So there's an incredible power over there. And as you look now for, I'm curious, do you invest or help out startups that are building stuff in your field?
Yeah, I mean, so one of the interesting thing is that I've made every single mistake that exists in running startups. So that's the value that I add to the people who ask me for help. So sometimes startups reach out to me and they say, "Can you help us?" And I'm like, "See if I'm interested in what they do, and also if I understand what they do," because unfortunately, I've seen a bunch of people who sometimes they advise startup, but they have no idea of the space where they are. So if I know what they're doing and I know people, I'm happy to help out. And sometimes they are people who don't have a startup yet. They want to build it, but also they are looking for the first people to do like a test. Maybe if I know somebody's, "Hey, well, you don't do like a test with these guys." So yeah, I like that because, as I said, I've made every single mistake that you can imagine. So every time something happens, I'm always like, wait a second, I have seen this. You should not be doing this.
What are the mistakes that you've made? Like the top two that you made. I know this was a curveball, but with the top two mistakes, you called it upon yourself. Like
Well, when I started Arduino, I was coming out of me working for a while for an investment fund. So I was kind of annoyed at the classic startup model where people sometimes start a startup because it was like a lifestyle thing before they even had like something they wanted to. They didn't have like a real problem they were solving. So I started Arduino mostly as with my co-founders as an open source project. So I would say we were not careful enough at the beginning. And so we had a problem with one of the manufacturers that we hired to do things, which basically, kind of took advantage in a way of our the fact that we were not structured as a proper company at the beginning. So we had to fight. So now, I have this law that says if you spend €1,000 in lawyers now, you are basically saving €1,000,000 in lawyers in like 6 years.
That's a really good advice.
Sometimes it's like €1,000 now, or €1,000,000 in lawyers in a few years. Now, so yeah, that's
the hard reality of open source is that you are putting it out there for the community. You're doing something good. There are people that are benefiting from what you're doing because you're open sourcing it, but you're more exposed, right? Is that what you've experienced?
Yeah, also you have to, one of the things that I realized is that the moment you start to become a bit successful and visible, a bunch of shady characters will start to
talk,
start to fly around you just to figure out if there's a way to sneak in. So you have to be careful. I mean, but I would say the biggest mistake was I wanted something that would be organized in a different way. So we started off mostly as an open source project. So we didn't sign enough piece of paper when we should have. And so we had to correct it later on, and it was much more expensive to basically fix it afterwards. So...
And what do you say today? So the way that I've learned how to code was by contributing to a small open source project on GitHub when I was very young, right? There was this Glucosio app. It's like an app for diabetics to keep track of their glucose levels. I knew a guy from my town that was contributing, and so I contributed, and I just started there, right? I think I remember the first 100 commits were not accepted. So I just, I tried to commit at the beginning. I was but what do you say today? What do you think today is the state of open source? It must have changed a ton since you started. And now open source has also become a lever for power. Like if you look at the LLM situation, it's a completely different way of doing open source than in the beginning. What has changed? What's your take?
Well, I think for some aspect, it's an exciting time for open source because obviously, you have big LLMs that are released free. So they're giving away expensive training and everything, which is great. It's creating an ecosystem of crazy innovations left and right, which is amazing. Obviously, what happens is that this type of open source projects are massive companies who are releasing part of their work to generate a community, to spark innovation, look at what people are doing, and incorporate the best ideas. So I would say there's an open source which is made like this, the Linux kernel. I would say the major contributors of the Linux kernel are paid by some company to do that, which makes sense because companies are using Linux to do everything, no? But obviously, it's not the open source that we had at the beginning, where there are still some great open source projects that are completely managed by the community. They don't want to become like a for-profit company, and it's great. It's just, it changes with the time.
What should a young person today that wants to approach the world of robotics, hardware building in general, even with tiny bit of coding knowledge, or maybe none, right? What should they do? What do you think is the best route? Because you're also a teacher. We shouldn't forget that.
I would say, I think it's also a very cultural thing. So, for example, my perception is that in Italy, the academic approach is to be very theoretical. Also because sometimes I guess the university don't have enough money for labs. So they say, no, study everything. While I think it's important for a young person to just start building stuff. Start building, start experimenting. There are now incredibly cheap kits that you can buy, or even stuff that you can download for free and make it yourself. So you can make, legged robots, robot arms, you can make whatever. So you learn how to program and how to do electronic like that. And then it's interesting because a lot of the things that they teach you in school with very little context, when you're using this approach, they become evident. I remember I was explaining to this kid how to program a robotic arm that Arduino makes. He was like 9 years old, but playing around, he came up himself with, he explained to me inverse kinematics. So, because he figured out that he needed to convert a certain position in space into the angle of the different joints. So the need for inverse kinematics, he came up with that, instead of a classic course where you have to teach. Then obviously you have to go and study the theory behind it, study the math and everything, obviously, absolutely. But to start like this goes over that initial hump that makes people kind of like, no, this is not for me. Because the moment you start to building stuff, then you start to learn about the different things. Then you start to study. When I was a kid, I sometimes I studied stuff that was in university books because I needed it to build something. Or I did control theory in high school, and then I was studying on these books from university because I wanted to build something with it.
So the precursor of learning the theory, it's likely, it's actually, you learn better the theory if the precursor to that is building something practical.
I would say yes. It removes the initial fear of like, this is too difficult. And at some point, it makes it clear to you why you are using certain bits of math, which is always complicated because unfortunately, sometimes, in school, people teach you a bunch of things and you don't have, I don't know, it's almost like sometimes I always had the feeling that knowledge that you receive needs to attach somewhere in your brain where there is already knowledge that makes sense with that. So if I give you a ton of knowledge with little context and I don't know how to place it, I will basically lose it. But if when the knowledge comes in, I know how to place it because there's a big picture that I understand.
That there's a big rabbit hole there with the Italian education system that I don't know if I want to take, but there's a big rabbit hole where basically, my degree and the degree of a lot of my friends in engineering, they end up becoming undergrad degrees in math, where you're doing so much mathematics. When you do aerodynamics, you're never going to wind tunnel, but you learn everything about the Navier-Stokes.
I mean, it is good because it prepares people with like a strong background and everything else. But I feel that we are losing a ton of people because these people, they become afraid. This is not for me. This is not something I'm interested in. While if you get young kids building stuff, then you basically recruit people that you would never imagine.
Yeah,
You know, I did this workshop, and there was this 15-year-old girl that came to this robotics workshop. She was already doing Arduino. She had a 3D printer next to her bed. And when I said, "So what are you studying?" And she was like, "I am studying at the classic, the classic high school. I hate it. My parents sent me. And, my friend in the technical high school are doing all these algorithm circuits." Like, wait, you will go to university. But, this young girl was fascinated by technology at some point. She started to build something. And then, she was super fascinated. And in a way, it's, I don't know, I think it was, we can recruit to the technology world and to the robotics world a lot of people that maybe would not join because they feel it's too complicated.
And now I've thought projects like Arduino, but also even just a YouTube tutorial on how to code anything, right? Or the YouTube tutorial on how to cut metal, do whatever. They make kids impatient in the positive way, right? They're just impatient to like build and see that outcome when everything around, they don't have any money. They're kids, they're like 13, 14-year-old. They can't go out and, buy the parts and break them or whatever. So they will be super scrappy in finding the cheapest things to build the cheapest product just for the feel of having it done and see it in their desk. I've experienced that and it blows your mind. I think it changes your mindset. What are you, and to kind of like go forward from there, what are you doing these days? What excites you? What are new projects that you're undertaking?
Yeah, I think, Arduino right now has management and all of that, so it's just on its own road. One of the things that I always liked is to take technology and make it understandable by people. So to me, everything is in the same scheme. So teaching, Arduino as a tool, but even when I helped organize the Maker Faire, now you have events, this event in Rome where we had 120,000 people over a weekend in 2019. And so, it was just 10 years that this big event happens in Rome and all of that. And it brings thousands and thousands of people. And again, you see these kids come in and they're like, "Oh my God, this is amazing." No? So those are all bits and pieces that I think serve the goal that I have. So what I'm doing at the moment, I'm working on a project called Super Moderno, which at the moment is mostly dedicated to the history of technology, but try to talk about where the technologies that we all know come from, but with the objective to clearly get some younger people to understand where technology comes from, but also to give the perspective to young people that there are some things in our society that they are the way they are because somebody decided 150 years ago that this is the way we do it. And when you look at it, sometimes you're like, but this is not practical at all. But it's because, now everybody learn how to do the thing that way. So if you look at this, it generates a lot of opportunities for reimagining the world. And also this idea that people like you and other have invented the things that surround us. There's also a mission that I have to show to people how, for example, women are present in science and technology. They are sometimes hidden away. They are not very mentioned properly, but they have contributed a lot because it's important for me, for young girls to see this and think that, technology is a career for them. It's something they can do brilliantly. And, my girlfriend is a software architect and, she learned how to program when she was 8 years old with a Commodore 64.
Wow.
But she was lucky that her father kind of encouraged this. And now she has a pretty, I would say, quite successful career being a software engineer. And she does a lot of work with young women because she understands that you need to, help people build their confidence. And so I like this idea that Supermoderno talks about, and now we are opening up to, for example, interviews with people. So I interviewed some of the people that are still alive who were part of the team who built the Olivetti Programma 101. I interviewing other people who are, important in the history of technology that are still alive. So I'm doing all this thing, but there's different ways where we can expand this.
And I usually ask at the end of these interviews, right here at BitBuilders, to kind of like end it on a positive note. I try to ask founders usually they are basically their suggestion or their advice for people that are building hard things like they did. But I feel like there's a nuance they can ask you that it's actually better in this word, which is, what is your advice to educators and people that want to become educators to engage, to create curiosity and impatience in kids? If you had to, distill it in one advice.
But it's not an easy question because
I
always felt that if you are an educator, you feel it. You feel it inside. You know what I mean? So it's something that you really perceive as a value. So for me, I think that education at every level is the only thing that changes the world. The world changes when people get educated and they understand the world around them better. They understand the relationship and the way the power works. Then they change, they push for change. So education is fundamental for changing the world. Everything else is, I guess, it's a consequence of that. So it requires people who feel it. There's a lot of people that I've had as professor in my life who I knew that they were there because it was a salary. And other people, for example, like a few days ago, the Italian TV released a documentary they shot about me, and they followed me for like a couple of days. And in one of these, I invited my professor from high school who taught me electrical engineering, and I invited him to come to Torino to visit the Arduino office. But his impact on my life is big. He was a mentor. He was somebody I looked up to. He gave me my first job. He taught me a lot of things. So if you are a real educator, you are passionate, you believe in really changing the world through empowering people, and you are available. When people ask for help, you're there because that's what you do. And sometimes being a teacher is not financially rewarding, it's a pity because, given the importance of teachers in society, they should be paid a lot. But the world is set up in a kind of weird way. But yeah, I would say if you want to become an educator, you should do it. It's a thing that has a lot of impact, but you need to believe it. It's a mission if you do it properly.
So be committed to jump on a mission. Don't do it because you think it's stable.
It's a mission.
I love it.
But I have a lot of former students who have done great things. And sometimes when they are in a situation where they need someone to say, hey, I want to talk about what I'm doing in life, and we do it. So it's nice. It's nice. You form connection with people that last years.
Well, I think it's a perfect note to end it in. I really want to thank you for spending some time with me and on BitBuilders, Massimo. It's
Thank
been
you for
really,
your
really an
time.
honor and a pleasure. I hope we can do a part 2 soon, and maybe next time I'm in Torino, I can take a peek at the offices. I'd love to.
Yeah, let's, I'm based in Lugano, but I go to Torino on a regular basis. So if you let me know, we can actually visit the office
I would love that. You have no
where
idea.
the R&D happens.
Where the magic is made. I love it.
Yeah.
Thanks, Massimo. Then
Oh,
have
thank
a
you very
great day
much.
ahead.
It was a pleasure.
Likewise.